They told three vectors are coplanar, so equate box product to 0. How to do cross product of two vectors? First row put I cap vectors, position vectors, create coinitial vectors. They give OA, OB, OC, OD. Create AB, AC, AD. AB is what? OB minus OA. In scalar triple product, if any one vector repeats, answer is 0. A dot B cross A. A is repeated, so answer is 0. If three vectors are coplanar, then their box product has to be 0. So we'll find box product. You know, box product or scalar triple product, both are same. Welcome to the session, dear students. Today we'll go ahead with the problems of scalar triple product. Find vector A dot B cross C if vector A is 2i cap plus j cap plus 3k cap. Vector B is minus I cap plus 2j cap plus k cap. Vector C is 3i cap plus j cap plus 2k cap. They want you to find A dot B cross C. So I told you in my last class you can do this problem in two methods. The first method is very simple. So A dot B cross C. So just you expand the determinant containing three vectors. First determinant of, in first row write the quotients of vector A. What are the quotients of vector A? Quotient of I is 2. Quotient of j is 1, quotient of k is 3. In second row, write the quotients of vector b. What are the vector b quotients? Minus 1, 2, 1, minus 1, 2, 1. Then write the vector c quotients, that is 3, 1, 2. 3, 1, 2. Now expand this. If you expand, so plus, minus, plus. So 2 into, delete the column and row where 2 is. You are left out with 4 elements. 2 2s are 4. Minus 1 into, delete the column and row, will have minus 1 into 2 is minus 2 and 1 into 3 is 3 plus 3 into, delete the column and row, will have minus 1 minus 6. So that is 4 minus 1 is 3, 3 2s are 6, minus 3 minus 2 is minus 5, minus into minus plus 5 and minus 7 into 3 minus 21. So this will be 11. 11 minus 21 is minus 10. This is a scalar triple product. So finally we got the answer as what? Minus 10. So now we can also do the same problem in other way. That is, first find the B cross C value. So A is given. Vector A they have given. What is vector A? They give 2i j 3k. 2i cap plus j cap plus 3k cap. And B cross C. What is B cross C? Vector B cross vector C is, we need to find. So how to find B cross C? Do cross product of two vectors. How to do cross product of two vectors? First row put I cap, j cap, k cap. Second row put write the quotients of vector B. What is vector B quotients? So that is minus 1 to 1, minus 1 to 1. Then write vector C quotients. What are vector C quotients? 3, 1, 2. 3, 1, 2. Now we'll expand this. If we expand I cap into, delete the column, delete the row, we'll have 2 into 2, 4, minus 1, minus j cap into, delete the column and delete the row, minus 2, minus 3, plus k cap into, delete the column and row, we'll have minus 1, minus 6. Now further 3 I cap, minus minus, it will become plus 5j cap, minus 7k cap. This is B cross C, vector B cross vector C. So now you got B cross C value, you know A value. Now we need to find A dot B cross C. Vector A dot B cross C. What is meant by A dot B cross C? Dot product of two vectors. How to find dot product of two vectors? Multiply the quotients and add. What is the quotient of I? 2. 2 into, what is the quotient of I here? 3 plus quotient of j. What is quotient of j? 1 into, what is quotient of k? Quotient of j is 5 plus, what is quotient of k? 3 into minus 7. Simplify this, it will become 6 plus 5 minus 21. 6, 11 minus 21, that is minus 10. So if you do by this method, first find B cross C. So B cross C, you will get a vector. So this is B cross C vector and you have vector A. So find A dot B cross C, you will get minus 10. So other method, so taking first row as vector A, second row as vector B, third row as vector C. If you expand again, you will get minus 10. So two methods, and this is better and easy and faster. So now we'll go to the next problem. Show that the vector A is equal to I cap minus 2j cap plus 3k cap. Vector B is equal to minus 2i cap plus 3j cap minus 4k cap. And vector C is equal to I cap minus 3j cap plus 5k cap are coplanar. Or what? Coplanar. So dear students, if three vectors are coplanar, then their box product has to be 0. So we'll find box product. You know, box product or scalar triple product, both are same. When you find box product or scalar triple product, suppose if you get 0, then they are coplanar. Now they give A, B, C. So let us consider box product of A, comma B, comma C. Box product is also called as what? Scalar triple product. Scalar triple product or box product means what? Expand the determinant. First row you take vector A quotients. What are vector A quotients? 1, minus 2, 3. Second row you take vector B quotients. Minus 2, 3, minus 4. Third row you take vector C quotients. 1, minus 3, 5. Now you expand this. If you expand this, it will become 1 into delete the row, delete the column. It will become 15 minus 12. Minus of minus 2 becomes plus 2 because plus minus plus. So minus of minus 2 is plus 2. Delete the column, delete the row. Minus 5 into 2 is minus 10. Minus 4 into minus 1 becomes plus 4. Plus 3 into, delete the column, delete the row. Minus into minus plus 6 minus 3. Now simplify this. So 15 minus 12 is 3. 1 into 3 plus 2 into minus 6 plus 3 into 3. Simplify this. 3 minus 12 plus 9. So 9 plus 3 is 12. 12 minus 12 is 0. So therefore you got box product when you calculated box ABC. Box, or we can also call it a scalar triple product, we got 0. So therefore what is the conclusion? Therefore the vectors, the given vectors, what are the given vectors? A, B and C. Given vectors A, comma B, comma C, B and C are what? Coplanar. So when can you say coplanar? Three vectors are said to be coplanar if their box product is 0. So now box ABC means first row you take vector A quotients, second row you take vector B quotients, third row you take vector C quotients and expand the 3 cross 3 determinants. In the chapter matrices and determinants, in determinants chapter you know how to expand 3 cross 3. When you expand you will get exactly 0. Since box product of 3 vectors is 0, therefore they are coplanar. Scalar triple product or box product, if it is 0, then we say the vectors are coplanar. Okay, we'll start with problem 3. So let us go to problem 3. We give 3 vectors. A, I cap, 3j cap plus k cap. B, 2i cap minus j cap minus k cap. Vector C, lambda I cap, 7j cap, 3k cap. They told they are coplanar. They give coplanar. You know, if 3 vectors are coplanar, their box product is 0. First we'll write what is given. What is given? What is given? They have given A, B, C are what? Coplanar. This is given. So when you read this coplanar, all of you know 3 vectors are said to be coplanar if their box product is given 0. That implies they have given box A, B, C is 0. So now we'll do this. We'll equate box product to 0 and we'll get the answer. So let us go to box product of ABC. Box A, B, C or scalar triple product of ABC is 0 because they are coplanar. You know, if 3 vectors are coplanar, then their box product has to be 0. That's why we equated to this. Now you know how to find box product. Box product means what? Determinant of. You should write the coefficients of 3 vectors. Vector A, vector B, vector C. Vector A is what? 1, 3, 1. Vector B is what? 2, minus 1, minus 1. Vector C is what? Lambda 7, 3. Lambda 7, 3. So now solve this problem. you know how to expand 3 cross 3 determinant. This is plus, minus, plus. 1 into delete the column, delete the row, minus 3 plus 7, minus 3 into delete the column, delete the row, 6 minus of minus becomes 6 plus lambda, plus 1 into delete the column, delete the row, 6 minus of minus becomes 6 plus lambda, 1 into lambda is lambda equal to what? 0. So 1 into minus 3 minus of minus 7 plus 7, minus 3 into 6 plus lambda, 1 into 4, this 1 into delete this. Oh, last column we have done mistake. Okay. Delete the column, delete the row, 2 7s are 14 plus 1 into lambda is lambda. So here substituting the values, carefully you should expand, delete this, so 2 7s are 14, minus of minus plus lambda 1 is a lambda, 7 minus 3 is 4, minus 3 into 6 plus lambda plus 14 plus lambda into 1 means same equal to what? 0. So further we'll simplify. So it will become 4 minus 6 3s are 18 minus 3 lambda plus 14 plus lambda equal to 0. Minus 3 lambda plus lambda is minus 2 lambda. Minus 18 plus 14 plus 14 18, 18 minus 18 is 0, plus 0 is equal to 0. So minus 2 lambda is equal to 0, or lambda is 0 by minus 2. 0 by any number is 0, lambda value is exactly 0. So we got the value of lambda. They want you to find the value of lambda. In the place of lambda we'll get what? 0. So this is 0. So let us just verify. So verification is not required. So put lambda is equal to 0 and expand. Now I'll take box product. Box product is what? 1 3 1 2 minus 1 minus 1 and lambda place we got 0 0 7 3. Now if we expand this we should get 0. 1 into delete this 3 plus 7 minus 3 into delete this 6 plus 1 delete this 6 minus 0 plus 1 into delete this 14 minus 0. So 10, then first one delete this 3 minus 3, this is minus 3, delete this minus 3 minus 7, minus 3 plus 7, 7 minus 3 is positive 4, minus 18 plus 14. So 14 minus 14 you will get 0. So therefore when I put lambda in the place of lambda, if I put 0 and expand, I am getting. So this verification part is not required, just I suggested you to verify, because finally your answer should be lambda equal to 0. If you get any answer here, they will give marks depending on the final answer. So in vector algebra, the final answer value of lambda what you get should be perfect. So lambda is what? 0. I hope all of you understood the method. Verification is not necessary, just if you verify it will be well and good, so that if you are wrong you can correct it by yourself, otherwise you lose marks. What they told 3 vectors are coplanar, so equate box product to 0 and you will get lambda. Next, let us start with the problem 4. The given, show that the 4 points A, B, C and D with the position vectors 4i cap plus 5j cap plus k cap minus of j cap plus k cap, 3i cap plus 9j cap plus 4k cap, 4 of minus I cap plus j cap plus k cap respectively are coplanar. They give 4 points and they want you to prove coplanar. They have given position vectors. So first write what is given. They gave position vector of A. OA is given, OB is given, OC is given, OD is given. So they have given position vectors. So from the position vectors you should create co-initial vectors. What is OA? 4 5 1, 4i cap plus 5j cap plus k cap. And what is vector B? Minus j cap minus k cap. If you multiply minus inside, then C 3i cap plus 9j cap plus 4k cap. Then multiply this, so minus 4i cap plus 4j cap plus 4k cap. So these are the position vectors of ABCD. Position vectors means what? OA, OB, OC, OD. So now we need to find AB. Vector AB means OB minus OA. OB minus OA. So if you do OB minus OA, you'll get AB. OB minus OA means subtract minus, so we don't have I, 0I minus 4I is minus 4I cap, and then minus J minus 5J is minus 6J cap, and minus of minus becomes plus, minus K is minus 2K cap. Then AC, what is vector AC? Vector AC is vector OC minus OA, that is C minus A. So 3I minus 4I is minus I cap, 9 minus 5 is 4J cap, 4 minus 1 is 3K cap. Then vector AD, what is vector AD? OD minus OA. So minus 4 is minus 8 I cap, 4 minus 5 is minus J cap, 4 minus 1 is 3K cap. So now you got AB, AC, AD. So minus 4 is minus 8, 4 minus 5 is 3, 4 minus 1 is positive 3. So now from the vectors, position vectors, create co-initial vectors. They give OA, OB, OC, OD. Create AB, AC, AD. AB is what? OB minus OA. AC, OC minus OA. AD, OD minus OA. These are our co-initial vectors. Now, so equate box, calculate box product. Suppose if box product of co-initial vector AB, AC, AD, suppose if this is 0, then the vectors are coplanar. How to find box product? Determinant of first row, vector A quotient, AB quotient. AB is what? Minus 4, minus 6, minus 2. Minus 4, minus 6, minus 2. AC is what? Minus 1, 4, 3. AD is what? Minus 8, minus 1, 3. Expand this carefully. So minus 4 into, delete the row, delete the column. 4th is a 12 plus 3. Minus 6 into, delete the row, delete the column. Minus into minus, so delete the row, delete the column. So minus 3 plus 24. Minus 2 into, delete the column, delete the row. Here plus minus plus. Minus of minus becomes plus. So delete the row, delete the column. It will become 1. Minus of minus, 8 4s are 32. Simplify this. Minus 4 into 15 plus 6 into 21 minus 2 into 32. So minus 15 4s are minus 60 and 21 6 are 60, 122 minus 64. Multiply this. Minus 4 into 15 is minus 60 and 21 into 6. 6 1s are 6, 6 2s are 12, 126 minus 32 2s are 64. So minus 60 minus 64 is minus 124. Delete this 1. Sorry, this is 32 plus 1 is 33. Now simplify this. 12 plus 3, 15. So minus 4 into 15 plus 6 into 24 minus 3 is 21 minus 2 into 32 plus 1 is 33. Now simplify this. Minus 4 into 15 is minus 60 plus 6 1s are 6, 6 2s are 12, 126 minus 66. That is minus 126 plus 126, that is 0. So therefore, what is the conclusion? Therefore, given points, say since you got scalar triple product or box product 0, so therefore given points, what are the points? A, B, C, D are coplanar. Given points A, comma B, C and D are coplanar. Next we have, prove that box of A plus B, comma B plus C, comma C plus A is equal to 2 times box ABC. See here, how to prove this? We'll take LHS, that is box A plus B, comma box B, B plus C, comma C plus A. And you know, box product can also be written as scalar triple product. So if I take, all of you know, 1 comma 2 comma 3, 3 vectors, vector 1, vector 2, vector 3, box product is same as what? Vector 1 dot 2 cross 3. So box product can also be written as what? Scalar triple product. So I can write this as A plus B dot B plus C cross C plus A. Now simplify this. A plus B dot B cross C plus B cross A plus C cross C plus C cross A. Now further simplify this. A dot B cross C. So dot product to do for all plus A dot next one, that is B cross A plus A dot C cross C plus A dot C cross A plus same thing we should do with B plus B dot the first term. What is the first term? B cross C. B dot, I'll write it here, B dot the second term, B cross A, then B dot C cross C, then B dot C cross A. Simplify this further. First one, A dot B cross C, I can write A dot B cross C. This can be written as box ABC. And second one, here A is repeated. In scalar triple product, if any one vector repeats, answer is 0. A dot B cross A. A is repeated, so answer is 0. Then here C cross C. C is repeated, answer is 0. The third one, again A repeated, answer 0. Fourth term, B repeated, B, so answer 0. And fifth one, BB. B and B repeated, answer 0. Sixth one, CC repeated, answer 0. Seventh one, BCA. Box BCA. We can write. So, last one, B dot CA. Nothing repeated. So, we should write B dot CA. Here, C cross A. So, scalar triple product can be written as box product. Box product can be written as scalar triple product. So, A dot B cross C, I can write it as box ABC. Similarly, the last term, B dot C cross A can be written as box BCA. So, now BCA is not in order. So, box ABC and BCA can be written as, so it is not in order. Scalar triple product, I taught you in my last class, scalar triple product is what? Cyclic. BCA, so it is in reverse order. So I can, okay, BCA is in order. A, B, C. After A, B, after B, C, C, A. So when you start from B, BCA, it is in order. So box BCA can also be written as ABC. Scalar triple product is cyclic. ABC is same as BCA, same as CAB. So instead of BCA, I'll write ABC. Now both are like terms. ABC plus ABC is 2 times box ABC, and we got hence the proof RHS. So they wanted to prove 2 ABC, we proved it. Then we have prove that box A, B, C plus D is equal to box ABC plus box ABD. Same method, take LHS and arrive at RHS. So let us start with LHS. Box A, B, C plus D. So box product of 3 vectors can be written as scalar triple product. A dot first one cross second one, B cross C plus D. Now simplify this further. A dot, so expand this, B cross C plus B cross D. Now again A dot B cross C plus A dot B cross D. Now A dot B cross C can be written as box ABC. I can write it as box ABC plus A dot B cross D can be written as box ABD. Hence the proof RHS. So they wanted to prove AB plus A, B, C plus D is ABC plus ABD. We proved it. We got ABC, we got ABD. This can be written as box ABC, this can be written as box ABD, hence the proof. Hope all of you understood this. So by this, I conclude the problems of scalar tuple product. We'll do the exercise problems given. Thanks for attending. Thank you.